Well, so hi, Bruce. How you doing?
Hey, how you doing, Ben?
Good. I'm Ben Hunsberger.
I'm Bruce Bagwell.
We're two of the guys who work at Verity Software House, and today we're going to take a look at how you can relate dot plots, scatter plots, um, with GemStone's expression profiles. You're going to help us do that?
I'm going to try.
Good.
Um, so we do a lot of these videos. We do a lot of presentations with probability state modeling. And many times we get questions about how does this new system relate to things that people know, which are dot plots. So we thought we'd put together this short video that would go through this in some detail. All right, here we have the program GemStone, which is Probability State Modeling and Graphics Package. And in the program we have 3 dot plots, or sometimes called scatter plots, which are showing all the permutations of CD45RA, CD28, and CCR7. Each dot in these dot plots represents a CD8 T cell in a specific stage of antigen-dependent progression.
Okay, so if we want to define a progression, we're probably going to have to know something about where something starts or where something finishes in the progression.
That's exactly right. We can't look at these dot plots and know nothing about the biology. We have to know something in order to get started. So we could either know the beginning of the progression, we could know the end of the progression, but we need to have some starting point. So in this example, we'll state that we know that, in fact, the progression starts right up here where this region is encircling the population. And this population, if we just look at this, is CD45RA positive and CD28 positive.
Gotcha.
But if we wanted to know what it is for CCR7, we could turn this region on and blink the dots that are inside it. And so we can also infer now that CCR7 is also positive for this beginning step of antigen-dependent progression. Now, the next thing we need to know is we need to know the initial direction of the progression. So we need to know whether this region is going to either go this way, or does it go down, or in some other direction. So we know that the initial thing that happens in this progression is that CD45RA downregulates. So it goes down in the direction of that arrow.
Okay, and I can see as you're doing that, that CCR7 is downregulating in a pretty coordinated fashion.
Exactly. So right off the bat, by looking at moving this region and looking at CCR7, we know that both of those are downregulating more or less at the same time.
Gotcha.
And we can even see subtleties where, as we're moving this down, you can see that CD28 actually increases intensity a little bit. So let's continue on. So we get all the way down to the bottom. Now at this point, the next thing that happens is CD28 downregulates. So let's start moving this region this way. And you can see that as I do that, the CCR7 remains negative. Then the progression comes up, and so as it's coming up, you can see that both CD28 and CCR7 remain negative.
Yep.
So just with that simple experiment with 3 dot plots and one region moving it around, we know that as CD45RA downregulates, so does the CCR7. And then after that takes place, CD28 downregulates. And then after that, CD45RA upregulates. And it's doing experiments like that is how most of the lineages in the hematopoietic system have been worked out in the past.
Okay, so I could see the relationships, but in looking at the distributions, it's still pretty complicated.
Well, it certainly is, and we're only looking at 3 dot plots. Imagine we were looking at 50 or 100 or 200. Obviously, the complexity would be just way too much for us to work out in this manner. So let's look at perhaps a better approach. All right, let's scroll up and look at the probability state model. Now, one of the first things that you'll note is that we have now an additional parameter. This parameter is calculated after the system has done its modeling, and it's a probability parameter. It's called cumulative percent, and I'll explain that in just a second. And then related to the cumulative percent or progression are the CD28 marker, CD45RA, and the CCR7. In order to understand what this progression marker, this progression parameter really is, let's turn on the animation for this region here. Now, the first thing you should note is that the percentage is roughly 10%, and notice that this region goes from 0 to 10 on this axis. And as we move this region to the right, you'll notice that the percent of events is always going to be roughly 10%. And so that's what really cumulative percent is. And the other thing to note is that not only do the percent of events remain the same as we move the region along here, but the area that's being lit up also is consistent from this plot to this plot to this plot, which is simply demonstrating that these are indeed the same parameter for all 3 plots. The other thing you should note is that these dots are just like they were in the dot plots, represent CD8 T cells in specific stage of antigen-dependent progression. But the nice thing now is that all these dots are ordered from left to right. So the events that are in the beginning are going to be our naive events. And then as we move to the right, we go through the progression.
And I can see that happening in the dot plots down below as well, Bruce.
That's right. So right at this point where CD28 is starting to increase in intensity, if you go down here, you can see that happening right here. And then you can also see over here that this is the area where CD45RA is just starting to downregulate. And notice that indeed CCR7 is also starting to downregulate. So we see these continuums right here in the dot plots. So all that's happening is that the probability state modeling has ordered the events in such a way that it now becomes almost trivial for us to appreciate complex patterns in progressions. So now let me keep moving here. So you can see that as I move left to right, the progression is moving down in the dot plots, which is what we showed before. And the other thing is that we could have this region in this, what we call an expression profile, or it could be in this one or this one. It really doesn't matter, since these are all the same axes. And now, as we move a little bit later on, you can see that CD28 is downregulating right here. And of course, you can see us moving over. So CD28 is downregulating, and we can see it up here. It's coming down. And as we keep moving a little further, all of a sudden we're going to see CD45RA start increasing, as it does right here. So basically, the relationship between the expression profiles and the dot plots is the only difference is that probability state modeling orders the events along this common progression axis. All right, let's put this region back to where it was, and I'll turn off the animation.
Okay, so I noticed over in the right-hand corner, Bruce, there's a little box. It looks like it's got maybe stages of the progression identified. You're probably going to want to tell me about that.
Thank you, Ben. I probably will. So the nice thing is that after the system has done the modeling, it knows exactly where CD45RA downregulates. So we can tell the system with what we call zones to color the dots between the beginning of the progression to the point where CD45RA just begins to downregulate, and we can call that naive. So let me turn this on, and let's take a look at what happens. So you can see that these dots are colored red, like they were in the beginning with the dot plots.
I can see that in the
and then you can see that our naive population now is lit up, and we can see it's also CCR7 positive as we did before.
Yep.
But of course, we can break the progression up into all its stages. So here we have central memory, effector memory, and effector cell. And we can see the progression in terms of colors right here, and we can see the color progressions, the corresponding color progressions down in the dot plot.
Okay, I see. And I can see that the dot plots, there are a lot of places where there's overlapping colors that would make it difficult to circle those with a region.
That is another advantage of the modeling, is that it works out the overlap between these various stages or populations, which is very important.
Cool.
So we can also show the progression with arrows, much as we started to do right here. And we can do that by selecting these three dot plots. And then what we'll do is we'll tell the system to show what are called state vectors. And you now can see the progression in terms of these little arrows. And we can get a little fancier, and we can actually animate the arrows, so you can see the progression in that way as well.
Oh, I see.
Now, since each one of these expression profiles is a pattern that's against the same axis, we have the opportunity to collect all these expression profiles and show all the relationships all at the same time in one graph. And let's do that. We'll just move over. And so that's actually what's happening here. The only thing that we've done is we've made these a fraction of their real width. So I think it's set to 20%, the real widths. So here in one graph, we now can look at all the markers that are in this progression and see what they're all doing as the T cells progress from being naive cells to effector cells.
And you've even got some that we weren't looking at in the dot plots up there.
Exactly. You can see that CD8 actually modulates a little bit here. We have CD27, which also changes, and CD57, which upregulates. So the advantage here is that in one plot, we can appreciate all the things that are happening in the biology.
That's a lot of dot plots you'd have to have.
There's quite a few dot plots that would be necessary, and it would be very difficult to work it all out. So that's it, Ben. That's it in a nutshell. We tried to show you the relationship between dot plots and expression profiles. And one of the things we went over was that you need some information to get started. The information's not in the data, so it has to come from either publications or somebody telling you what the progression is, but it has to come from outside the data. And then we just we talked about expression profiles, what they are. They use a common marker called cumulative percent. So we can see all the correlations against that common marker, and it doesn't matter how many markers we look at.
Very cool. Thanks a lot.
That's it, folks. See you at the next show.